Welcome back to another video on A-level maths in Edexcel. This is last video on functions, which will cover section 2.5, 2.6, 2.7 on this book, the Pure Maths Year 2 book. Okay, and it will be covering the topics of transformations and modulus problems with this, okay, which is section 2.5, 2.6, 2.7. The first thing you need to learn about this particular section 2.5 is what is the difference in the graphs of y equals f of x in the whole modulus, which you've done in the first chapter, first exercise, and y equals f of just x in the modulus. Okay, I will try to explain this to you with this question. This is just like question number 3. If x is 2e, I've changed the numbers. So I would like you first of all to draw a graph for this if you can, otherwise we'll do this graph together as well. So I'm going to pause the video and you start it after you've drawn the graph yourself. Alright, I'm expecting you to have known this by now. Because this whole function is factorized already, let's find the x-intercepts for all of them. So x-intercepts are when this factor is 0, 0, then 2, then 3, then minus 4. And then we need to find the y-intercept. Give you a chance to do that as well. So as you can see, y-intercept comes out as 0 because when you put x equals 0, you'll get y equals 0 as well. Now, this is a quartic curve. You've done that in the previous videos or in the previous lessons. And it is a positive x to the power of 4. So it's going to be this shape like quadratic, but instead it's going to have 3 turning points in between somewhere. Okay, so curve is going to come from here. I'm going to draw with the blue as well and go up somewhere. We're not interested in the minimum point at the moment. Come down, pass through 2, then go up and pass through 3. Guys, this will be the shape of the graph y equals fx. Now I would like you to do this part because you've done this in my first video and in the first exercise of this chapter. Draw that graph, please. Thank you. Okay, so for this graph, you can see that the output, the y, cannot be negative because every output is coming out of a modulus function, and that can't be negative. What does that mean? Wherever y is negative, like in these two portions, they'll be reflected up. So I'm going to do it with black pen. Okay, and this is going to be the graph of y equals modulus of fx. I'll show it just like this here. That is a graph of y equals modulus of fx. Now guys, this is really important to understand the difference now. In this particular bit, x is in the modulus. What does that mean? The input can't be negative. Whatever goes inside the bracket is the input, and that is coming out of a modulus. The input can't be negative. In my previous graph, which was this one, input, the x is positive, positive, positive. But the moment it comes and goes over here, the input becomes negative. So guys, this part of the curve will not be there. So what happens then? This graph will be reflected back into the y-axis. So this will be, I hope I do it properly. That will be the curve, okay, and this 2 will be here coming out as 2. This is, I haven't done it properly, look, this should go, so I'll do it here, guys. This is the right side portion which we have. Okay, that's a 2, that's a 3, and this will be reflected in the y-axis, so that comes there, this comes down, and this goes like this. Guys, this is minus 2 and minus 3. So this bit is the graph of y equals f of mod x. Try and see the difference here. The input cannot be negative, so the positive input graph will be repeated on the left side, and here the output can't be negative, so any graph which is below the x-axis will be reflected up. For the next exercise, we talk about combining transformations. I'm not going to do much about this because we've done all of this in first year's course. This is on page 44 of the book, so you can take a look at that. And then after you've done, all right, so for exercise 2f, like I said, I'm not going to do much. I've copied a question for you, which is like question number 3 of the book. This is the graph of change few numbers. The asymptote horizontal one is y equals 0, which is the x-axis. Vertical asymptote is x equals 4. There's a point which is y-intercept, which has got 0, 2. I would like you to copy that graph and do these 4 graphs, draw these 4 graphs. What do you think is the answer? Then I'll go over with you in a minute. Okay, so pause the video, do these 4 questions, then check with my answer. I'll run you through step by step. Okay, let's do the first one together. Right, guys, inside the bracket, it hasn't changed from y equals fx. That tells you no change in the input, or x doesn't change. For y, you're going to do twice of fx first, means what? Every y coordinate will be times by 2. Then after you've done that, you got to do take away 5 from y one more time. That means the graph will be shifting down 5 units. So when graph is going to be shifting down 5 units, so this asymptote will be y equals minus 5, and the vertical asymptote does not change because x, there's no change there. So this is still 4. Okay, so this point 2 will be first multiplied with 2 to get you 4, then shift 5 units down, so 4 take away 5 should be minus 1. Alright guys, so graph will be something like this, and this portion will be coming like this. So that's your first graph. There are 2 extra x-intercepts which you can work out using algebra. Let's try and do the next one now. Okay, then for the second one, the input has changed this time, so x has changed to x plus 3. That means graph will shift left with the coordinates with 3 units. So this will be minus 3 shift on the left. Okay, so that means this horizontal asymptote will be shifted to 1, and then graph is then shifting up by 5. So this is the whole transformation. So what do we do, guys? We do the asymptotes first. So that will be x equals 1, and it will be y equals 5, and this point is x coordinate doesn't change. X coordinate, okay, is 0, so this point will be somewhere over here. But where would it cross the y-axis? That's important, x point, because this will be minus 3 somewhere, and it will be crossing the y-axis on 2 add 5, 7. So guys, this will be the graph. This is 7, and the graph will be this. Asymptote, horizontal asymptote shifted 5 up, vertical asymptote shifted 3 left, and the point here from 2 to go up to 7. Okay, try and do these 2 now one by one. Right, this is the real good one actually. The x changes to 2x. What does that mean? Graph is going to be squashing in, or every x coordinate will be divided by 2. That will affect this asymptote. That means this asymptote will be on x equals 2 this time. Okay, no change in y, but then afterwards there's a negative in front of it, or all the y's will be negative. That means the graph will be reflected in the x-axis. Let's do this one by one, people. So asymptotes will, this one will stay the same. This one will come here on x equals 2. Then this would be the normal curve. This 2 would stay at 2, but then what's happening? It's negative sign in front of it. So that means every y will be negative, or it will be flipped down. So graph will come like this. All this you've done in previous year, guys, and this will be -1 for point A. Well done. Now the next one, new one. Let's try and do number 4. Okay, so this is the new learning now, people. Here, input cannot be negative. And for this whole curve, input is positive, no change. For this curve up to this point A, input is positive, but then afterward, input starts getting negative. So guys, like we did in the previous question, this portion will cease to exist because there's no answer for negative input, but this portion will be reflected on this y-axis. So no change in the vertical asymptote or horizontal asymptote. This curve stays completely as it is. This one will be coming here to point 2 again, but then what happens, people? This portion red will be reflected here, so this will be here -4. Graph goes like this, then graph goes like this. Obviously you can do better reflection than I did. So guys, this is the graph of f of mod of x when the input cannot be negative. All right, the last exercise, the last section 2.7 is about solving modulus problems. It says you can use combination of transformations, which we have just done, together with these two to solve, you understand, domain and the range and solve problems. Domain and range you've done in the previous videos. So guys, we're going to do just one question of this. You can read this first. It starts from page 48. Then we'll come back and do a question with you. Okay, the question I picked up is like question number 4 of exercise 2G. I've changed few numbers like we always do. Can you just copy this question and try and sketch the graph? You've done that before, you should know it. Once you've done the graph, you can see how the range of the function means how high or low the graph can go. Then solving this equation, you've done that as well in my first video. Okay, so try and work that out, then we'll show you the solution, share the answers. Okay, I'm going to go over this sketching of graph in step by step again. Okay guys, step 1, we draw the graph of y equals x plus 5, which is a straight line. Okay, and this is 5 and that's -5. Y equals x plus 5. This is how I teach you sketching the graph, guys. This is, I think, the best value. Okay, then I'm going to do the modulus of that. So y equals modulus of x plus 5. So this portion stays as it is, then it's reflected. So this will be a v, that's a 5, and that's a -5. Okay, now we go on to stage y equals 3 times modulus of x plus 5. Guys, listen, once you practice it, you don't need to do what I'm doing now. You can just draw it straight away. So what happens? Every y coordinate is multiplied by 3. So 5 will go up to 15. So we will be rising up sharply. Okay, and that's -5 still, that's 15. Then the last stage, y equals 3 of x plus 5. And the v is plus 2. The whole v is going to be shifted 2 units up. That'll be 17, and this will be 2. Okay, so that's the final graph. What you're going to do now, people, to find the range, and fairly straightforward, like I said, how high or low graph can go at. You can see graph can go low at 2. So range is fx is greater than or equal to 2. Okay, because it can be 2 as well. Then people, to solve this equation, you're going to see this is a negative gradient straight line passing through 2 somewhere over here. So it might cut both the lines of the curve of the graph. So you're going to be writing 2 equations. This will be 3 of x plus 5 plus 2 equals -3 over 2x plus 2, or it will be 3 of negative of x plus 5, the 2 modulus values, plus 2 equals -3 over x plus 2, -3 over 2x plus 2. Solve these 2 equations and work out the answer, then we check with mine. So the 2 answers I've got is -10 over 3 for the positive side of the curve, so somewhere over here, that's -10 over 3, and -10 for the negative side of the curve, somewhere over here, that's -10. You know, guys, check your algebra. I might have made a mistake somewhere, but I'm pretty sure you can check and do this equation yourself. That finishes our unit on functions and graphs. So you can practice all the exercises. Is there any issue? Do email us. We can get back to you with a detailed solution of that question. Bye bye. Happy learning. We come with next video soon.